Next in this lecture, we'll see the decision-making statements. So this is where the core of C programming getting started. Yeah, because till now what we saw was very rudimentary, like the operators and other things. But actually what we are starting now will be the basis for our programming. Basis as in we need these if conditions. Yeah? We have operators, say relational operators, greater than. Okay, if A greater than, do something. Right. So those such things are achieved by using this if, elseif, and switch case. So now I have here we see if true. We will not simply just like that write true here. True is a condition evaluated. Yeah. So true or false. Either it's greater than, not equal to, correct? So anything which evaluates to true. Yes. And then execute some expression if it is true. False, meaning other than true. True can be anything, which is not that. If A equal to 50 is true, double equal to 50. A is something else, anything other than 50, please come here. Now, what if we have three expressions? Yeah. If A equal to B, then expression 1. A is greater than B, expression 2. Then else. Okay. So this is how we have, we can use the if, else, elseif and else conditions. And there is one more way to do this multiple evaluation of the if condition or multiple expression execution using the different decisions. Yeah. Like here we're only comparing A equal to B. Okay. What if we have A equal to 1, A equal to 2, A equal to 3? We might end up writing a lot of if, else, if conditions. So just to avoid that, there is one more decision making statement called switch case. What this switch case does? Yeah. So switch case, here we have. So here we'll take the expression. Okay. This expression say switch A. Yeah. And then next here comes case 1. If it is 1, expression 1. And this, you're seeing it for the first time. This is a break statement. Every time after executing a case, there is a break statement. Okay. So I'll explain you what this break statement, why this break statement is needed in switch cases. Or can we use this only in switch cases? No, this is a generic expression, can be used in multiple places according to the need. So what I have written is, if constant expression is true, that means if A is actually 1, I'll write 1 here. And then expression 1 is executed. And if I don't write break here, then it will simply go to the expression 2. It will just evaluate, okay, even if it is true or false. Then similarly, if it is break, then it will come out of the switch and execute the next statements. So we saw some theory topics for if, elseif and all, but we'll see now how to use those if, elseif, switch cases in here. So let's see how to use if. Yeah. So I already have a function and int a. Let's accept int a via keyboard. Yeah. Okay, accept int a via keyboard. If a equal to 20, quickly write it. This is just to use if else. Yeah. Let's compile it first. And now we'll see the build output of this. So what we'll do, I'll enter some number. First, I'll enter the true case. That is, if a equal to 20. It has come and executed this. Value of a is 20. Okay. So how did this actually work? Is if. It's actually if asking a question. And the syntax is same. Okay. Here the syntax are very important in C program. We cannot use capital I here. It has to be in small letters. So a double equal to 20. So this expression what we have here will be evaluated to true. And what we saw in the previous slide says if this is true, then it will execute this statement. This is an expression. Okay, we are only using, for demonstration, I'm using printf, but it can be anything. Correct? So then this is the else case. Yeah, else means if not this, then do this. Yeah, let's see what happens there. I'll not compile. I'll directly run it again because it's already compiled. And 1. Value of a is not 20. Actually executed this statement because is a double equal to 20? No. A has to be only 20. Then it will execute. Let me use the same. I'll slightly change this to this. A not equal to 20. So build, compile. Okay. Anything if a is not equal to 20, it is going to print this statement. Okay. Yeah. I entered a equal to 1, which is not equal to 20. So this expression, this is a expression which is evaluating a result which is either true or false. Yeah. So then it will come here. So it need not always be true. Meaning it need not always evaluate it true. Let me do it this way. I remove this whole thing and we'll see what happens. So the build output. Now I'll just write 5. Okay. Anything which is greater than 0 will usually is treated as true in this case. Yeah. So just to show this example, yeah, if a, but if you are a programmer, you're actually not making any decision by just writing if a. Okay. It is a C compiler which is treating it this way. So usually what we write is we use some expressions. Correct. We'll see some other example. We saw if and else. So let me give you a real-time example. So instead of a, I'll write button. Yeah. So consider if the button is pressed equal to 1, then turn on light. Yeah. If it's not on, then I want to turn off the light. Okay. I think it's same as what we saw before. I'm just giving you a real-time example that instead of printing, you can actually go and send a signal in this scope. This is what we call scope. In this scope, you can send a signal to turn on the light. So these are real-time examples where we can use. So, and we saw if else, and let's take an example of elseif. I'll take it back to the a variable a, and the previous example. I have if a equal to 20, this one, else if a greater than 20, greater than 20. So in this case, if either it is 20, it's greater than 20, it has to, else is less than 20, right? Only 3 cases are possible. So what we have here is if, else if, and else. So it first evaluates if a equal to 20, yes. Then it will print this and it doesn't bother what we're doing here. Because if you see, there is one more check here. Yeah. Yeah. It will not execute this one. Okay. First we'll see the if else, and then we'll see after first execution, even though the second if is true, it will not execute that. I compile it. This is a software. This is the build output. Let me first print 20. Yeah, it's printing 20 as we saw last time. I will take one more input. I'll take 30. Yes, value is greater than 20. And next one is else, correct? So I'll just take 1. It's less than 1. Fine. So now let me add a case where this is greater than 10. Okay. A value is the value which is greater than 10 will come and execute this statement. Okay. So what if I add 30, right? 30. That is greater than 10, also greater than 20. But according to this flow, it will come here. If 30 is greater than 10, yes, it will print this. It will not worry about this. It will not print the statement as well. Let's see that. Compile, build. So these are the basic confusions what you might have. I'll just add 30. Okay. See, just printed this expression. 30, he is greater than 30. 30 is greater than 10. Yes. Print it. 30 is greater than 20. Yes. But it's not printing because it's else if. Yeah. So now, what if we want to print both? Because both the cases are true, correct? If a is greater than 30 is greater than 10, true. 30 is greater than 20, that's also true. In that case, I cannot use else if, because if else means if not this, then only do this. If this is done, then it need not worry about this. Okay. So if I still want to evaluate this and execute this, I will add like this. If, one more if, and this else is for this if now. Okay. Let me compile it and run it. So you will see 2 expression getting printed. Yeah, value of a is 20. Value of a is greater than 20. Let me add a new line character just to make it more beautiful. Let me add 40, which is again same, right? First this got executed if, yes. Since there is no else if, yeah, it's just a plain if. So this if what we have here, it ends here. The syntax is only this. But whereas for this if, we have these two. Yeah. So if it is not greater than 20, it will come and print this now. If I write 21, 21 is greater than 10. Yes. 21 is greater than 20. Yes. Sorry, it will print this. So for me to print this, a should be less than 20. Okay. So let's see how this happens. A should be less than 20. So I'll write 19. Yeah, so just wrote 19. So what you saw is it's printing first one, all good, 19 greater than 10. Is 19 greater than 20? No. It will come and print this. So this is how the if else have to be carefully used. And there is one more care I want you all to take care while using the if else. Say you are using double equal to. Yeah. What if I use just single equal to? Does build fail? No, it won't fail. And the moment we write this, the whole thing will be, the whole if else will not be useful, because only if will get executed, because this whole expression will always become true. Yeah. Unless you write a equal to 0. It will always write, because whatever I enter a, it's going to update that value. I'll write 100 is greater than 20. Just to show what's happening here, let's print the value. I'm just printing the value. I'll write 50. See, I wrote 50. Since it again got assigned to 20, and it is true, it will become true. So here, we're not achieving what we wanted to achieve, and there is no compilation error as well. Yeah. So just to avoid these situations, I recommend in equals to cases, always use this. Yeah, this will also work. Build, compile, I'll write 50. See, it is coming here. And what if I do this? The build fails. Yeah, if you erroneously do this, the build is failing. So this itself is a trigger for you why the build is failing. Because in the previous case, build did not fail. And you're always thinking the if is executed. Yeah, but whereas it's not doing anything, it's always executing the if statement. There is no relevance of else. So these are the expressions which potentially will add a bug. But these are not, there are many standards in the coding guidelines, and there are many tools which identify such things. But this is one of the way of coding practice with which you can avoid such things. Yeah. So this is what I wanted to highlight in this one with this example. And now we'll see the nested if else. Yeah. What I mean by nested if else. If within if. Okay. If a greater than 20. Okay, all good. If a greater than 30. Only if a is greater than 20, it will come inside. And is a greater than 30? Yes. Printf a is greater than 30. And I want same value here. Let me print it. Is greater than 20 and a new line. Let's see what it will print now. Okay. Well, first we'll do the static analysis of the code, what we have written. So we are accepting a value from the keyboard. Say we give 30. Yeah, I'm only using if. I'm not using if else. So this statement also will work. We can only use if, because if there is no use of else, we can ignore it very well. If a is greater than 20, it will come inside. It will print this. It will execute this expression. And then if a is greater than 30, it will execute this expression. If not, then it will just return, simply return. Yep. Let's build it. Okay, build this through. Compile, run it. Now I'll add 21. Okay. Only one expression. 21, yes. Second one, no, because 21 is not greater than 30. Let me run it again and try to make both the expressions true. Yeah. See, both the expressions are becoming true. So this is how you can use the nested if also in your programming. And the real-time applications are huge with if else. Yeah. A lot of software will mostly be running on if else. Of course, functions will be there, but inside function will be using if else's. Pointer structures are there, but with if else we can achieve a lot of logic. So see here, it still executed without an else. So else is not mandatory. Can I write only else? That's not possible. Else if also is not possible. You have to start with if. You can have if and one more if. And how many time nesting we can do? We can do as many time nesting as we need. But a lot of nesting is not recommended. If you need a lot of nesting, then I think it's better to split the code and find a better way to implement it.